Okay, so this video is going to go over questions 29 and 30 in homework 2.1. And then this one in 29, we have to graph a square root function. Okay, so let's go ahead and click on our GeoGebra thing. Let me bring this over here. And this is what we want to do. We need to position these 5 points so that they graph this function, which is f of x is equal to square root of 4 times x, so that they all line on the graph. Okay, the biggest trick about this is to make sure that you use the right x values so you actually get something useful. Now, so we have that f of x is equal to the square root of 4x. Now, the idea behind one value of x that we can possibly use is 0. If x is equal to 0, then 4 times x is equal to 0. And then the square root of 4x is going to be equal to 0. Okay, so with that in mind, we can take this and I guess we can start with a and put that over there. Okay, now, what we want to do is you want to choose those values of x so that 4 times x is a perfect square so that we can actually snap these things to the grades, which is kind of like what we need to do. So if what we can do is let x be equal to 1. Why? Because 4 times 1 is 4, which is a perfect square. So we let x be equal to 1. 4 times x is 4. And the square root of that is going to be 2. So then our next point is going to be the point 1, 2. One, 2. There we go. All right, now we really can't use 2 because that will give us, we can't use 2 because 4 times x is 8 and the square root of that is not an integer. But what we can do is use x equals 4. Why is that? Well, because 4 times 4 is 16, and the square root of 16 is 4, and that will give us the point 4, 4. Okay, so we can take C, and we can put that at 4, 4. All right, the next perfect square is 9. Okay, 9 times 4 is 36. The square root of 36 is 6. So that gives us the point 9, 6. Okay, so we can take D. There is 9. And we want to go up to 6. Make sure we're on 9 there. Okay, yeah. And then the last perfect square, or the next value of x that we can use is probably, once again, is a value of x that's a perfect square. That would be 16. 4 squared is equal to 16. So let's use x is equal to 16. 4 times 16 is 64. The square root of 64 is 8. So that's going to give us the point 16, 8. So we can make E, go up to 8, go over to 16, and that should be our graph. And there you go. So the key is for this particular one, you want to use, well, basically 1, 4, 9, and 16 for your values of x, no matter what problem you have. I probably don't want to say that, but basically you want to choose those values of x so that this becomes a perfect square. And typically, if x is a perfect square, and if your argument, and if this coefficient is a perfect square, you'll be fine. Actually, let's just look at another one real quick. Yeah, so once again, 9 is a perfect square. So if you use 1, if you use values of x which are 1, 4, 0, 1, 4, 9, and 16, you'll be perfectly fine. Okay, so the next one's question 30 right here. Once again, it's one of those GeoGebra ones. And let me get it over here. And here we want to position these 5 points so they so that they fall on the graph of the equation f of x is equal to 3. Okay, so or I'm sorry, f of x is equal to x cubed. So we basically have x, and then we have x cubed. Now an obvious one would be x is equal to 0. When x is 0, x cubed is 0. So we can take a and put that there. Another one would be 1. If x is 1, x cubed is, well, 1 times 1 times 1, it's 1. So that's going to be the point 1, 1. We can put b there. The other one is going to be 2. We can use 2. All right, and then 2 cubed, well, that's 2 times 2 times 2, or 8. So c is already on 2. We can just move that to 8. Now, we could try 3. 3 cubed is 27. There's only one slight problem. We can't go all the way up to 27. So we can go we've gone as high as we can as far as x values are concerned. And this one won't work because we don't have a 27 on the graph. But we can go the other direction from 0, which is negative 1. Negative 1 cubed is negative 1. So we can take d and put that at negative 1, negative 1. And then we're back to 2, negative 2. Negative 2 cubed is negative 8. Negative 2 times negative 2 times negative 2. That's negative 8. So we can put e here. And there you go. We can check our answer. That should be right, unless I really screwed something up. There you go. And that's how you would do that. Now, if you had to do another one, here we have the absolute value of x. Well, that we're going you can do that the exact same way. So we would have x, the absolute value of x, and typically you want to use these values of x. In this particular case, I don't think you have to, but it probably wouldn't hurt. So here we're going to let x be equal to 0. If x is equal to 0, the absolute value of x is 0. If x is 1, the absolute value of x is 1. If x is 2, the absolute value of x is 2. So we can put b at 1, 1, c at 2, 2. We actually could put d at 3, 3, and e at 4, 4, and that should actually be sufficient because it just says to put all the graphs all the points so they lie on the graph and that don't coincide, and the absolute value of 3 is 3, the absolute value of 4 is 4, and so we would have the points 0, 0, 1, 1, and so forth. Let me see if they will actually take this, and they do. Of course, they kind of hint right here that they wanted you to plot points over there to get the, to get the phi thing going, but still, it works just fine. Okay, and that, in a nutshell, is how to do those two problems. If you require further assistance, just get a hold of me, and we'll figure something out. This is Bob Boyle, signing off.